So today we go with chapter 5 about the looping. So in this chapter, you will learn about the advantage of the looping, using the loop, control variable, nested loop, avoiding a common loop mistake, using a for loop, using a post-stat loop, characteristic shared by all instructed loop, common loop application, and similarity and difference between the selection and loop here. Okay, now the advantages of loop. Looping makes the computer program efficient and worthwhile. So write one set of instructions. So when working in the loop, you need to write only one set of instructions, but you are able to operate it for multiple times. You need to do it for one time, but you are able to execute it and run it for multiple times. Right? That's why it's less time required for design and coding, fewer error, and shorter compile time. The loop is a structure that repeats action while some condition is continued. So on the chapter 3, you learn something about selection, right? When the selection, you have the condition to check. And in the selection, you break it down in 2 branches. If the condition is true, you do something, and if condition is false, you do the other thing. The loop also, the loop, remember that when in order to do with the loop, you also only need the condition to check it. That's the thing you have to remember. The loop also you need a condition to check, and if the condition is true, you keep doing it again and again and again. And if the condition is not true or false, you exit the loop here. Okay, so now let me give example that I had some of the job in the I think about some of the job here in I'm not sure on the internet or not. Okay, this one. I take this one. Now I take that you have the image here. What is this? I am not able to find the image here, but that is a job that in the school, and some students make mistake, and the teacher asked him to write this "I'm sorry" for 100 times. Right? They say you have to say the sorry for 100 times. So if you want to do the coding with this one, right? So normally if you work in the router, here, right? So is that free now, right? It's a free now. I'm sorry here. Okay, so we see this was do it for one time, right? You run it here. I'm sorry. And you have its output. I'm sorry here. And now if you want to do it 2 times, you just do it 2 times here. Right? And so on. Okay. But see, if you have to do it for 100 times, you see, you just copy for 100 times here, right? So it's very, very long program here. So instead of that doing in the sequence here, you can take advantage of doing the loop. And remember, if you want to work in the loop, you only have the condition to check. And if the condition true, you keep doing it here, right? So now think about this one. If you want to do it for 100 times, you have to maintain the counter here, right? So for this one, you do it for 4 times. And in order to loop, you have to maintain the counter and to tell how many times you want the loop to do it here, right? So for this one, you can see. For this one, you can initiate the counter here. So you can you have assignment. You have the counter here. You have a counter at the beginning. You set it to number 0 or 1, whatever. Right. So now, remember when working the loop, you always have the condition to check. At the loop, when working the route after, you work in the loop here. Now you want to do it for 100 times, right? you want to do it for 100 times, so we put the condition here, counter equal to 100 here. So, see, whenever you have the counter equal to 100, you exit the loop. You can put it here. You can put it here. I'm done with sorry. Okay. Now see, you maintain the counter, right? You maintain the counter 0, and now the condition here to check if the counter equal to 100, you exit, and you want to do it for 100 times, right? You want to do it for 100 times, so you just put it here. You just put it here. Say I'm sorry. And one more thing about the loop here, you have to maintain the counter variable, right? You have to initialize the counter variable. The first one is 0. The second one, you always have the condition to check. The third one is that you always have to make the change to the counter here. You always have to take the action to change the counter inside the loop. Otherwise, it is an infinite loop here. Now, if I run this one here, you see, right now I run this coding here. What happened? It is an infinite loop because the condition here is the counter is 0, and it never ever meet the condition of the true here. That's why it's only no, and it do it again and again and again and again forever. It is infinite loop here. You can see now if I run it here. So you see, it's only true because the counter here is always 0. It never ever reaching to 100. That's why it keep doing it forever. It's an infinite loop, right? So that's why, in order to work in the loop, you have three things you have to remember here. You have to initialize the counter, right? The second one, you have to check the condition of the counter here, it's true or not. The third one is that you always have the action to change the counter in order to exit the loop here. Otherwise, it's an infinite loop. So, what do you think for this one? How can you modify the program? How can you modify this program to force it exit when it do for 100 times here? What do you think? How can you modify it? Any idea?
You'd have to minus it somehow. The count, right?
At the beginning 0 here, right? And you want to do it for 100 times. So 1 time, 2 times, 3 times, 4 times, 99 times on 100 here. So what is action? What do you think? What is the action you have to do here? How can you count 1, 2, 3, 4, 5, 6, 7, and 99, 100 here? How can you do it? At the beginning you have 0 here. How can you do it?
I know you showed us before, but I can't remember.
Okay. So here, you just have the option here, right? You just have the option here. The action here, sorry, you have the action here. So every time you have the counter increase by 1 here. That's all, right? Counter equal to counter plus 1. So you see, 0, now 1, check, it's not 100 yet, right? Check it again, 2, 3, 4, 5, 6, 7, 8, until 100 here. It makes sense?
Yeah, sorry.
For the loop here, for the counter variable loop, you have the 3 things you have to remember. You have to initialize the variable, but when you initialize the variable, you have to put it outside the loop. That's the first thing. Outside, you have to initialize the counter variable outside the loop. The second one, you always have the condition here to check. And the third one, you always have the action to change the counter here. Otherwise, it is an infinite loop. So you see, for this one, you can run it now. Let me clear this one here. So now you run it here. Okay, so now you do it for 100 times. Okay, so that is the way you work in the loop. Okay, so we see instead of doing the I'm sorry for 100 times in the sequence here, it takes very long time with the coding, and it takes the coding very long here. It's very hard for you to keep it up with the coding, right? To follow up is coded here. So we see by using the loop, you have some of the advantage here, right? You can what is it? Sorry, this one here. Okay, so what is it? Oh no, I think it has an advantage here, right? It's a less time required for the design coding. You have a fewer error, because you only use it for one time only. So if something wrong, you can go back and you can change the coding for one time only instead of 100 times here. Right? So you see, less time required for design and coding, fewer error, and shorter compile time. Actually, it's a shorter compile time here. So now, what is the loop again? Yeah. What is it? Okay, so now it's a comparison between the, I think it's a, okay, no, this one is the selection structure, right? So you action for the two. What is it? Okay, so here's the loop structure, right? So we see that you always have the condition here to check, and if yes, keep doing it until the condition is no. But one thing you have to remember that when working with the raptor, it's a little bit reverse here. So we see when we see the interrupter here. That is something you have to pay attention when you work with the raptor. So basically, in the pseudocode or in the flowchart, when the condition is true, you keep doing it here. Right? But in the raptor, when the condition is true, you exit the loop. So remember one thing, that when working the raptor, a little bit reverse in the condition here. So normally in the pseudocode and the flowchart, when the condition is true, keep doing it. But in the raptor, when the condition is true, you exit the loop. That is something you have to pay attention when working the raptor. Okay, so here it is a body of the loop. It is a logic common to many business programs. Right? You have the declaration here. You have housekeeping. Housekeeping is everything about initialize. Right? So you initialize some variable. For the last example, you just set the counter equal 0. You can think about this one is a housekeeping. Right? Housekeeping is a step of initialize some value to some variable here. Right? And now you move to the body of the loop. Body of the loop, you have the condition to check. If yes, keep doing in the body of the loop here. Body of the loop is that for this one is a print out absolute here. Right? And remember, in the side of the body here, you always have the action to change the counter in order to exit the loop here. Right? And of course, the last one you have the end absorb here. Okay, so now using a loop control variable, that is the example I give you in the raptor. You have the loop control variable, and the variable here is the counter. Right? And for this one, you know for sure you want to run it for 100 times. That's why you can use a loop control variable here. You starting with the 0 and keep changing it every time the loop. Every time the loop execute one time, you increase the counter by 1 here. And you know for sure this one is running for 100 times. That's why you can use the loop control variable here. Right? So as long as the condition remains true, the statement with the while loop body execute here, and the control number of repetition, you maintain the counter here to control the number of repetition. For this one, you know you can do it for 100 times. Right? So the loop control variable initialize before ending the loop. You have to remember that something here. That 3 things here you have to remember in every time you do the loop with the loop control variable here. Okay, so here, the loop control variable, you have to initialize before ending the loop. You have to initialize the counter number outside the loop here. If you look on the raptor, I set the counter equal to 0 outside the loop. Right? Now, you have the loop control variable test. You check the correction. Right? So in the raptor, you see at the beginning, I set the counter here. I set the counter equal to 0 at the beginning. It is an initialize. and it must be done outside the loop. Now the loop control variable test, it check the condition if counter equal to 100 or not. If it equal to 100, you exit the loop. That is the condition. Now the third one also variable, very important here. The body of the loop must here enter the value of the loop control variable. So we see if you don't have the action to counter, if you don't have the action counter equal to counter plus 1, you see the counter always stay at the 0 forever, and it never meets the condition 100 here to exit the loop. That it comes to the infinite loop here. So that's why the first one here in the body of the loop, you always have the action to change the value of the loop control variable, and in that way you just increase it by 1 for every time. Okay, so the repetition control by the counter here, you do it for 100 times, and in order to exit the loop, actually you have the two ways to do that. The first one is the counter. So for this one, you just do it for 100 times. And when working a counter, you know for sure you want to do it for 100 times. And the second one, you can use the sentinel value. Sentinel value is that you to create the indefinite loop. So we think about if I want to print out the sorry for multiple times, I have no idea. It can be 100 times or 10 times or 1,000 times. I keep doing it until the user want to exit it. So we have the question: do you want to continue it or not? So if you want, put yes. If you want to stop, put no. That's what that is sentinel value here. So now I can change it here. If you look on the interrupter program, if you look on the interrupter program here, this one is a counter. I know for sure they wanted to do 100 times. Now think about the teacher asked you to write for multiple times until the teacher want to stop or not, right? So you can think about this one. You can send if you put here, you edit it here. Now I think it's here. You have input here. Yes, so now I store it into the variable input. Input I got it from end user. If you want to continue, press Y. If he want to stop it, press N here to stop. So that is a sentinel. Now we check the condition. We check the condition here. If input equal to for this one, yes, I exit it. Exit yes. And of course, you have to initialize the initial here. Input here. Sorry, no here, right? No, you exit it. No, you exit it. Okay, so we see if you enter the no, you exit it, but not no, that means yes, yes. Keep doing it. Actually, for this one, you have to modify it here. Every time you have to do it again. You have to ask it again if you want to continue or not. So see, now I run this one. I run this one. I put yes to continue here. I'm sorry, one time. Yes, I want to do it one more time. I want to do it one more time. I want to do it one more time. And now I don't want to do it. I put N here. Check condition and exit. So that is a kind of sentinel here. Sorry, can you see it? I think I have to change the font side here. Okay, so you see this one. Actually, I think I have to clear this one. Let me run it again for the router. Let me run it again here for the router. So yes, I want to continue. Yes, I want to continue. Yes, I want to continue. And no, I don't want to continue. So I see. So we see this program is not the same with the previous program. In previous program, you know for sure you want to run it for 100 times. That's why you control it by the counter here. But this one, you can run it many times. It can be the 5 or 10 or 100, whatever, until you enter no here, right? So this is a control by the sentinel. That is sentinel. The keep doing it until you enter something you don't want to do it anymore. Right? So you got the idea what's the difference between the control the loop by the counter and the control the loop by the sentinel? Do you think you can get it? Hello?
Yeah.
Okay. Okay, so we see the repetition here can control by the counter. That is previous example. You maintain the counter, and when the counter equal to 100, you exit. And for this one, it is a definite here. You know for sure you want to do it for 100 times. The second one is sentinel value. You keep doing it until you enter some character or something to stop it here. Okay, so now when working with a definite loop with a counter, that is example we're working with 100 times, right? That executes a predetermined number of times. No, for sure, this one I want to do it for 100 times. Right? It's a counter control loop or the counter loop here. Program count loop repetition and loop control variable until by it can be incrementing or the decrementing here. It doesn't matter, right? So think about if you want to print out the even number, if you want to print out the even number now from 100 to 0, you can do it with a decrementing here, not always incrementing, right? And any counter here, counter is any numeric variable. Remember, in order to do with the counter, it might be in the number format here. It's a numeric format here. And the counter number, it is restarting 0, but it doesn't always have started 0. You think about if you want to do it for if you want to do print out the even what is it? If you want to print out if you want to print out the even number, 50 even number from the 1000 and down into for 50 times, you can starting from 1000 here. It doesn't always have to be starting with 0. And you're totally flexible with the counter here. The counter, but remember one thing, the counter here is always in the number format. That's the thing you have to remember. And you can control it by the increasing or the decreasing here. Right? Think about this one. Again, right? What is it? Oh, sorry. Why? Okay, so here's the example of the, sorry, this is the this is a diagram of the definite loop, right? You have the declaration here as the num count is 0. That is example you when you starting with the counter 0. But remember, you can starting with any number. It's not always 0 here. Right? So now for this one, you see, this one you want to print out hello for 4 times. You know for sure you want to do it for the 4 times. That's why you have initialized the count here 0. So we have 0, 1, 2, and 3. You have 4 times, right? So that's why the condition here, if count less than 4, that can be 0, 1, 2, 3. Keep doing it, right? Keep doing it. Print out the hello, right? And remember here, you have 3 things you remember. You have to initialize the counter outside of the loop. That's the first one, right? Outside the loop here. The second one, you always have the condition to check the second one here. The third one, you always have the action to alter, to change the counter here in order to meet the condition. Otherwise, it keeps always at 0 and it is an infinite loop. It never ever exits here. Okay? So again, you have to remember about the 3 important things when working with the loop. Initialize outside the loop. Condition here to check, right? And you have the action here to change the counter. Otherwise, it is infinite. So for this one, you want to do it 4 times, right? Starting with 0. So whenever it's less than 4, keep doing it for 4 times. And when it's go to the 4, you access the loop here. I will see. So when you run this program, sorry. So when working with the pseudocode, right, your declaration is starting with the number count 0 outside the loop, and you have y and y here. It is the body of the loop. Right? Y and y is the body of the loop. And if you look inside the coding here, this is the initialization. Right? This one is the body of the loop. In the body of the loop, you have the condition to check, and you have the action here to change the counter. That's all. Okay, now in the case in define loop, you work in the sentinel here, right? And loop. Again, you also have to initialize the sentinel variable. Right? So we see that is the initialize here. That is the initialize here. Right? You want to do continue or not? Yes or no? Right? So now you do something with the input should continue here. Input should continue here. So you have to tell that. Do you want to continue, right? Input should continue, so you have to put yes or no for this one. Remember, that is the initialize. You have to do it outside the loop. That's okay. The first one. Again, you have the condition here to check. You have the condition here to check. And again, you have to action here to got the input from end user. If he want to continue or not here. Right? That's all. That is working with the sentinel value here. Okay. And it perform a different time of each time the program execute. So for this one, you can do it 3 times for this time, and the next time you want to do it 5 times or 10 times, it doesn't matter. Keep doing it until you enter no here. And the user is the one who decides how many times the loop execute. That is the user who decides here. Okay, so that is example here, right? Do you want to continue? Yes. Print now hello. Do you want to continue? Yes. Print now hello. Continue. Yes. Hello. No. Goodbye here. Right. So see 1, 2, 3, and 4 here. Okay. So you have understand the loop in program mainline logic. You have the 3 steps occur in every properly function loop. Right? That's the 3 things I already highlight here. The 3 things I already highlight here. You always have to remember you have the 3 steps here. Right? Provide starting value for the variable, control the loop, and this one must be outside the loop. Right? Must be outside here. Outside the loop. Right? The second one, you always have the condition here to check. Right? Condition here to check. Condition to check. And the third one, you always have the action to change the loop control variable inside the loop. Otherwise, it is an infinite loop. Right? So we have to remember about 3 things when working the loop. Any question? Huh? Any questions so far? Everything clear or not? Let me know.
I'm good.
Okay. Now, the loop is a program logic. You think about this one, right? So again, if you look on the overview, every program you have the housekeeping, you have the body loop, and in the body loop you have the detail loop here. That is everything inside the loop, and you have the end of the job here. So think about this one. You have this program here. You can have the sum of the thing. You have the string name. You have the gross. You have deduct. You have net. You have rate, and you have quit. You have report head link. You have column head link. You have deduction net. You have the end line here, end of report. So see, this is initialize. Sorry, this one is the initialize step here. You always do it outside the loop. So what is housekeeping? Housekeeping here give you that enter the quiz name, quit or input here. I input the quiz name here. So you see the quiz name here. If you want to exit it, you just enter the quiz to exit it. Otherwise, it keep doing it, right? Check condition here. It not quit. Keep doing it. Keep doing it inside the detail loop here. Oh no, I think
you skipped some.
Okay, sorry for that.
Yeah, it's okay.
Why? Okay, it's too much. Again. So for this one, you have the housekeeping. Right? Housekeeping is initialized outside the loop. You have the output report heading. What's the report heading? You have the payroll report, right? You have the output column heading. You have the name, gross, deduction, and net here. So actually, when you print out, you will have something here. You have payroll record. Right? That's the first line. And the second line, you have name for the first column. You have gross for the second one. You have deduction for the third one. And you have net here for the fourth one. So everything here is in this line. Print out in the Zocrate. The next one here, you have to initialize it. Right? What is the name? Remember that the name here. If you want to exit it, you enter the quit here. Right? That here. So when you want the name, you have the condition to check here. If the name is not equal to quit, keep doing it the loop and working the detail loop. What's the detail loop here? You have to input the gross and you figure out what the deduct. What you figure out what's the net. And print it out here. Print it out. So you say here, David, 100, deduction 15, the net here, the 85. You done with the first customer, right? Remember here, when you're done with the first customer, you always have the action to add here for the next customer. That also, if you don't have this one, it is infinite loop here. You have three things, right? Initialize outside the loop, check the condition. You have action to change the variable in order to check the condition. And you see, first one, second one, and the third one here. That's all. That's all we're working with the loop here. Now, working the netted loop. That is loop. And sometimes you want to put one loop inside the another loop. That is the netted loop here. Loop within the loop. And in that, you have the outer loop. That is the loop contains the other loop. And you have the inner loop. The loop is that is contained here. The netted is when the value of two or more variable repeats to produce every combination of value. Let me give you an example here. Think about this one. Think about this one. You have the quiz. For the quiz here, you have the 5 parts. You have the 5 parts. And for each of the quiz, you have the 3 questions. For each of the quiz, you have the 3 questions here. So you can think about this one. You can think about this one here. You have the quiz here. The first one, you have the quiz. So we have the quiz number 1, quiz number 2, number 3, quiz number 4, and quiz number 5 here. You have the 3 quiz. 5 quiz. And for each of the quiz, you have question here. You have question. For the question, for each of quiz, you can have the question number 1, question number 1, and question number 2, and the question number 3 here. So see, when you're working the quiz number 1, question 1, question 2, question 3, number 2, question 1, question 2, number 3, and go on here. That is the netted loop. You have the inner loop and you have the outer loop here. So we can think about the quiz here is the outer loop, and the question here is the inner loop. It's an inner loop here. So you can check it. Sorry. You can check it again. You can check it again here. You have the 5 quiz, and each of the quiz you have the 3 questions here. So now you do this one. Again, you have the housekeeping. You have the condition here. If you want to continue or not, if you enter the quiz, if you enter the name, it is a quiz. You exit the loop. Otherwise, keep doing it here. So here, the thing with this one. Now, if you look on the flow chart here, you can clearly see, right? You can clearly see here. This one here is a loop. This one a loop, and this loop here is totally inside this outer loop here. Totally outside, inside the outer loop. So you see, this one is the outer loop. This one is the outer loop here. And this one here, the inner loop. You put one loop inside, totally inside the outer loop. It is netted loop here. Remember, you have to put it totally inside outer loop. It's a netted loop, right? So think about this one. You can think about this one here, right? So for this one, you have 5 quiz. You have the 5 quiz. That's why you run it everything from 1, 2, and 3, and 4, and 5. This is outer loop. But remember here, every time you do one iteration or one time of outer loop, you have to do everything inside the inner loop. I see, starting with the question number 1, you do the question number 1, question number 2, and question number 3 of the first quiz. Right? So when you've done everything with 1, 2, 3, that means you complete everything for the inner loop here. So when you complete everything in the inner loop, you go back to outer loop, you move to the next one. That's the question number 2. Again, you have to do 1, 2, and 3 questions for the question number 2. So when you're done with the inner loop again, you have to go back to the outer loop, you move to the next iteration, the question number 3. Again, you have to do 1, 2, 3. Okay, that is the way working with the netted loop. Remember, when you execute the netted loop here, every time we do one iteration with the outer loop, you have to do every iteration inside the inner loop. So when you're done with the inner loop, you go back to the outer loop and you move to the next iteration. Okay. Okay, so here is the thing about this one, right? So we can see it is how it works with the flow chart and the pseudocode here. So actually for this one you have the what is it? What is the part here? You see the part here is number 3. Sorry, the part here is number 5, right? So actually you compare it to part here, or compare with this one is the part here, right? And what is the question? Question is number 3 here. Question number 3 here. You see, you initialize the outer loop here. Part counter is number 1. That is the first quiz, right? You have the first quiz. So see, now I starting with the first question. Now I do the part counter here less than 5. The condition is true, right? The condition is true here, right? So you starting with the inner loop here. In the loop also, you also have to initialize the variable for the counter of the inner loop. Remember, this one is a counter of outer loop, counter of outer here, and this one counter of inner here. This one is counter of inner. Right? So see, every time you do with the counter here, starting with the number 1, right? And number 1, check the condition here. It's correct. You move to the inner. Inner, you have the counter number 1 here, right? The counter number 1. Now we do it. 1 less than 3, correct, right? Keep doing it. Counter now come to 2. Now do with the question number 2. Number 2, check it, less than 3, correct, right? Do it to the question 3. Question 3 now is a 4. 4 is greater than 3. So we know. Now here, what happened? You have to change the outer counter here to 1. So now you move to the number 3. Sorry, you move to the number 2 of the counter here. Right? When you move to the number 2 of the counter, this is the outer loop. Again, you check now 2 less than 5. You do it again. So we do it again. 1, 2, 3. Now we move to the 3. 1, 2, 3. Now we move to 4. 1, 2, 3. And then 5. 1, 2, 3 here. Okay, that is the way working the netted loop. Remember, in the netted loop, you have the outer loop and the inner loop. Inner loop put totally inside the outer loop. And every time you do one iteration with the outer loop, you do every iteration of the inside of the inner loop. So when you've done every iteration of the inner loop, you move back to the outer loop and you move to the next iteration of the outer loop here. You got it or not? I think it's quite confusing, but I hope you can understand the overview of this one here. Can picture it here. It makes sense?
I think I understand, yeah.
Okay, got it. Thank you. Okay, so here's the same, right? You can look on the pseudocode here. Right? You can see the pseudocode. You have the netted loop here. You have netted loop here. So here, this is a y and y here. It's the outer loop. It maintains everything 1, 2, 3, 4, 5, which here. And this one here, y and y here is the inner loop. It maintains everything about the question for each quiz. So we have the 1, 2, 3 here. Now done with the inner loop, move back to 1 to the outer 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3 here. That's all. That's all. But remember, the rule is always the same. whatever working with the outer loop or inner loop, the rule is always the same. You have to initialize the counter outside the loop. The first thing, you have to check the condition here to make sure to check if you want to exit or not. That's the second one. And inside the loop, you only have the action to alter, to change the counter here. Now think about this one here. You can think about this one, right? So for this one, what happened here? You have the part counter here, right? That is the out. That is the outer counter. Outside the loop, outside the outer loop here. That is the initializer the counter, right? So now when you move to the inside loop here, this one also, this is the inner counter here. Inner counter. So you see, it's also this one put outside of the inner loop, right? So we see when we working with the inner loop here, this one initializer the counter outside the loop. You have a condition here to check. Now the action here to change it here, right? Every time you increase the question counter by 1. So if it's equal to the number 3, you exit it, right? Now you go back to this outer here. You have to initialize the counter. You have the condition to check here, and you see you have to change the counter here, right? So you all have the action to change the counter. So we see starting the one in the question here, 1, 2, 3, 1, 2, 3 of the inner loop. 1, 2, 3 of the inner loop. You increase the counter here to number 2, 1, 2, 3 of the inner loop. You increase the counter here to the 3 and keep doing it here. Okay. Okay, so netted loop facts, the netted loop never overlap. That is something you have to remember. You totally put the inner loop inside the outer loop here, completely contained within the outer loop here. And inner loop go through all of its iteration. I see for this one here. The inner loop go through all of its iteration. You can think about the example here. You have the quiz number 1, 2, 3, 4, 5. It's the outer loop. For every iteration of the outer loop, you have to do with 3 questions here. 1, 2, 3. So see, an inner loop go through all of each iteration. 1, 2, 3. Each time each outer loop go through just one iteration. You see, when you done 1, 2, 3, all the iteration of the inner loop, you move to the next one. You increase the 1 for the outer here. And the total number of iteration executed by netted loop is the number of inner loop iteration times the number of the outer loop iteration here. So you can think about this one. You can think about this one. You have the 5 quiz, and for each of the quiz, you have the 3 questions here. So what do you think? How many times program have to execute here? What do you think? How many times program? What is the total number of iteration? Iterations, that means each time the loop do it 1 time. What do you think? What's the total number of iterations?
Would be 15.
Yeah, right. You have the 5 quiz, and each of the quiz you have 3 times. So we see 1, 2, 3, 3 times. 1, 2, 3, 6 times. 1, 2, 3, 9 times. 1, 2, 3, 12, and 1, 2, 3, 15. And that's all. Remember, every time you have to do all of the iterations of the inner loop, and you move to the outer loop, and you increase by 1 iteration of the outer loop. Okay, so you have to avoid some common mistake in the loop here. Failing to initialize the loop control variable. It's always the rule of the 3 things here. Initialize the control variable outside the loop, check the condition, and have the action to change the counter variable inside the loop. That's all. If you miss any one of them, you got problem with the loop here. You got the problem with the loop here. Now you can think about the router again. You can think about the router again here. Now, if you don't have this one, what happened here? You have the syntax error. Because it don't understand what's the input here. And that's why you have to initialize it outside the loop here. That's the thing. So You have initialize inside it. You always have the condition to check. And this one also, if you don't have this one, it is infinite loop here. It do it forever. It do it forever. It only, I put it yes here. So when you put yes, it only yes forever, forever. It never know. That's why it do it forever, forever. Okay. So that is again, that is the same rule here. When working the loop, remember you have three things. You have to remember it. Initialize the variable, the control variable outside the loop. You only have the condition to check. And inside the body of the loop, you only have the action to change the variable of the counter variable here, or control variable here. Okay, so for this one also, right? You have to input the name in order we have something to compare with the quit here. Otherwise, how can it compare to quit? So, okay, what is it? Okay, you don't have, right? This one here, you don't have the name. You're missing the input here. You're missing the input here. Initialize. That's why when you're missing the input here, when you're missing the input, right? When you compare this one, you have the syntax error. You have syntax error because the program do not understand what's the name here. What's the name here? You have nothing in the name. You have nothing in the name here. Okay. The other one is neglecting the enter the loop control variable. That also, right? If you're missing anything with the counter chain here, it is infinite loop. It never ends here. It never ends. That's something you have to remember. That. Okay. Using the ROM comparison when the testing loop control variable, the programmer must use a correct comparison and seriously depend on action performed within the loop. Overcharge insurance customer here. You think about this one. If you make a mistake with the action inside this loop, right? What happens if you overcharge the insurance customer by 1 month? Overbook a flight on air line application or dispense HR medication to patient in the pharmacy. It's a huge problem here. Right? So wrong comparison when testing the loop here. Let me give you an example here. So, I'm going to come with this one again. Now for this one, I want to maintain the counter here. Put it 0, right? And of course, every time I have to include the counter to 1 here. And the condition here, right? If you want to do it 100 times, you have to check it. If the counter equal to 100, you exit here. Alright, what's the thing here? Somehow I make mistake. I make mistake with the comparison. So instead of the counter, I put the 100. I make mistake. I put it to negative 100 here. So it's good. You see, it's starting with 0, and every time you increase the counter to 1. That's why the condition here, you never ever got the condition counter equal to negative 100. That is a mistake in combination as well. So that's why this program here, so it is an infinite loop. It do it again and again and again forever because every time it's a counter that increase from 0 to the 1 to 2 to 3 to 4, and it never ever have the chance to equal to the negative 100 here. So you can see this again, this is infinite loop, right? The condition here is only it never ever true. That's why I keep doing it again and again. That's why when working the loop also, you have to pay attention to the comparison here. Okay. So why every time it's go back? Okay, so some the wrong operation when testing the loop control variable. Now what else? Okay, this one here, right? This one, the name greater than which. It's not correct, right? That name is not equal to which here, not greater than which. Okay, that is the wrong comparison here. Now, as a mistake here, including statement inside the loop that belongs to outside loop. I take example for this one. Discount every item by 30%. Right? And because this one. Okay, so now this one, think about this one. You want to discount the item by 30%. And for each item here, you have the 100 sticker for that. Right? So instead of doing outside one time only, you move it inside and you have to do it for 100 times. That's why you see you increase the processing time of the program. You consume a lot of the processing resource of the computer, slow down the process here, and you consume more memory for the programming. That's why you always have to pay attention. You have to think that if you want to move it outside or inside the loop. So if you move it outside, you just do it for one time only. But you move it inside the loop, you have to do it for 100 times. And it's the same output here. What else? Okay, so we see, you just move it outside here instead of inside. Right? You see, it's the same, it's totally the same. You move it inside, you have to do it for 100 times here. Even though they're always the same, But if you do it, move it outside, you just do it for one time only. Okay, now we're using the for loop. It's a for statement or the for loop is also definite loop. Now sometimes when you look in the pseudocode, you have the for here. Yeah, for here. Remember for the for, it is definite loop. You know for sure how many times you want to execute with the loop here. So for this one here, now you have starting value is the 0 here. It's the same with the while loop, right? You have the initialized value is 0 here. Okay. So when you compare the for and the while here, you see they work the same here, right? So for the while, you have the initialized value outside the loop, right? And you check the condition here. If count equal to less than or equal to 3, keep printing the hello, and every time you have to change the counter variable by 1 here. Right? So when the counter is the 4, you exit the loop. The same with this one here. For count is 0, that is the initialize. Right? That is right here. Now, you want to do it until the 3. Right? So 0, 1, 2 here. Right? 0, 1, 2, 3 here. And you do it every time you have step here. Step, that means every time you increase the counter by 1. Right? Increase the counter by 1. You see? So if you have the 0, you have 1, you have 2 and 3, you print out the hello. But if you have 4, the 4 not in the range from 0 to 3, you exit the loop. So it works always the same. So actually exactly the same with the y here. Right? Sometimes so we work. So when we're looking in the pseudocode with the for statement, you can think about the y and y loop here. You have the condition here. You have to initialize the condition here. The condition to check is that run until the number 3. And every time you have to take action to change the counter over here, it increase by 1. And for the count here, you can change the step. You can step by 2, step by 3 or 5, or you can step by -1, -2. It doesn't matter. You're totally flexible with this one. Okay, so we see that's the for here, right? Initialize the count variable, right? Check the count variable again, limit number 3, right? If the evaluation is true, you have to take action to change it to increase by 1 here, right? And of course, the body here is that print out the hello. So the way it works totally the same with the y and ny loop here. Okay, and the step value is the amount which the loop control variable change. Can be positive or negative. It doesn't matter. It's totally up to you. you totally flexible with that. It can be increased or decreased or by the positive or negative here. And the default step is number 1, but of course you can change the step. It can be 2 or 5. So think about if you want to print out, if you want to print out the even number or the even number from 0 to 100, you can do it. Right? So we think about this one. You 4. I think about this one. You can have a 4 here. Or the number equal to 0. That is starting point. That is like here. Right? To 100 here. And step. Now, if you want to print out the even number, step cannot be 1. Right? Step here is number 2. So we put the number 2 here, and you print. Print num here. That's all. You see? Starting with 0. Print now 0. Now increase by 2. 2 is not 100 yet. Print 2 and 4 and 6 until you go to the 100. And of course, you can change step here to number 2 here to print out the even number. Right. Okay, so while statement could be used in the place for the for statement, and they are pre-test loop. You have the 2 types of loop. You have the post-test and you have the pre-test loop. The pre-test loop is the loop. The control variable is set before each iteration. So before doing the loop, the body of the loop, you have to check the condition first. If it's correct, do inside the loop. Otherwise, you exit the loop. That's the practice loop. For and while loop, they are pre-test loop. They are pre-test loop here. Now, you have the post-test loop also. You have the post-test loop also. Post-test loop is a loop control variable is test after each iteration. After each iteration. So in the post-test loop, the loop body execute at least 1 time before the loop control variable is not tested until after the first iteration. Alright. So you have the do and while loop is the post-test loop here. So here, example, do pay bill while more bill remain to be paid. So you see, you only do the pay a bill first. Right? After that, you check if you want more bill or not. You exit the loop here. So we see in the post-test loop, the body of the loop always execute at least 1 time because the condition is checked after that. But in the pre-test, sometimes you don't have to do anything inside the loop because if you check the condition and condition true, you exit the loop here. Okay, so now let me give you an example here. Again, for this one. For this one here. I don't know how to increase the font here. Okay, so if you look on this program, what do you think? This is a pre-test or post-test here. It's a pre-test or post-test. What do you think? If you look on this program, this one is a pre-test or post-test.
Pre-test.
Yeah. See, that is the body of the loop, right? That is the body of the loop here. And you see, when you go to the loop, you check the condition first. If not no, use a P now, I'm sorry here. Right? Sorry, I have to do it one more time. Okay, so that one is a pre-tag here. So now what happened here? If I work in the pre-tag, I put no here. So it exits immediately. Actually, it have nothing to do with the loop here. Right? It have nothing to do with the loop. It's exited immediately. It have nothing to do with the loop. That is pre-test. That's why the condition is checked before you do it with the body in the loop. But now what happened here? I move this one before this one. This one right now is the post-test. Because you see, I don't care. When I go to the loop, I just pre now, I'm sorry for the first time. At least one time. Right? After that, I check the condition. If no, you exit it. If yes, you keep doing it here. So this one is the post-test. So we see in the post-test here, the body of the loop always execute at least one time. At least one time. Because the condition is checked after here. After that here. So see now, I don't want to print it here. Huh? I put no here. I put no here. No, I think it should be better if I clear the script here. This one. So now if I run it, if I run it here, I don't want to continue. I put no. But it print now, I'm sorry, one time here. Right? Because it's a condition to check after that. That's why this one is a post-test here. So remember for the post-test, the body of the loop is always execute at least one here. Right? And so you have the pre-test, you have the pre-test and you have the post-test here. Pre-test, you work in the for loop, and y, and ny, and y. They are pre-test. And when working with do and y here, they are post-test. So just do it. After that, you check the condition later. It makes sense?
Yeah.
Okay. So I think it's very straightforward, right? So we do example here, very straightforward for you to understand what is a pre-test and what is a post-test here. So if you look into the flow chart also, see, check the condition first. After that, do the body of the loop. That is a pre-test here. But for this one here, post-test, just do it one time first. Right? After that, you check it. So we see, only have to do it for one time, at least one time. Okay, so we have to do and y here. Do while loop, to do the same thing. So if you have the while loop here, you do it for one time outside of the loop. After that, you check the condition. That is the same with the do while. Okay. Now recognizing the characteristics shared by structure loop. All structure loop have the three characteristics. The loop control evaluation must provide either the entry or exit from the structure, and the loop controlling evaluation provides only entry or exit from structure here. And some language support the do until loop also. It is the same with the do and while here. The name is different, but the way it works is the same. It's a post-test. Okay. Okay. So remember, you remember about structure of the loop here, right? So you remember that you also you have to you remember about the prime input also, right? So you have to do it outside the loop here. This one is not good. The on the left here is not good. You have to do it outside the loop. You have to initialize something. You have to do with the prime input here. Outside the loop, you check the condition. If yes, do something inside the loop, and again, you have the action to get another input from the user. So I hope you remember about everything about the prime input, right? You have to initialize the input outside the loop, right? And when you're working with the body of the loop, again, you have the action to get another input from the user. The common loop application is using the loop to accumulate the total. Think about if you want to figure out what is the total number you enter, you just maintain the counter. Sorry, you maintain the accumulator here, right? And every time you enter the new number, you add it up to accumulator. Think about this one. I think this one. No, I think this one. Here, think about this one. You have the program. You have to write the program. Is that you asking the end user to enter the number, right? Enter the number, and every time enter the number, and at the end of the program, you have to print out what is the total number the user enter. Okay, so think about this one. For every program, you have to figure out what is the expected output and what are the input here. What are the expected output and what are the input here. So this program here to ask user to enter for multiple input, multiple number here, and out at the end of the program, you have to print out what is the total of this number. So what do you think for this program? What is the expected output here? Expected output. What do you think? What is the expected output for this one? What do you think? Total, right? You want to print out what's the total here? Total. And the input it is a number. It is a number here. So the one time you can enter the number 10, next time the number 20 and the 50 and the 100 here. So we see the action of the output, it can be 10, 20, and 50. It is a repetition, right? Enter the new number, enter the new number, enter the new number, enter the new number. It is a loop here. You should do the loop here, right? So in order with that one, in working with the total here, you only have to maintain the accumulator here. Later, accumulator. So normally, if you want to figure out the total, you have to maintain the accumulator. So the total here is accumulator. So set here at the beginning. If you want to figure out the total at the beginning, you only have to set the total equal to 0 here. You see, at the beginning, you have variable and the total here is 0. That total is 0. So what happens here? So every time you maintain the loop, right? You maintain the loop. You may ask the user if you want to continue or not, or you can tell the user that keep enter the number until the number until you enter the number 0 here. Right? So we said keep enter the number 10, number -15, or whatever it is until he enters the number 0, it exits here. Right? So here you have the conditions to check. You have the condition to check, and every time the user will input here, you got the input and it's input number here. Input number, right? So think about this one. If he enters the number 10, if he enters the number 10 here, so what's the total now? If he enters the number 10, what's the total now? What do you think? What do you think?
10.
Yes, right? You only have one number, right? So how can you figure out 10? You have to put here total. The total equal to total plus number. Right? So what is it? The new total. That is the new. That is the O here. So see, what's the O? At the beginning 0 here, right? And what's the number? He enters the number 10. That's why now we have a number 10. So the next time, if he enters number 20, so what is the total now? What is the total now?
You said for 30?
Yeah, so 30 because the O here, the 10, right? And number here, 20, you plug it to the 30. That is the way working with the total here, right? So when we figure out the total, you always have to maintain accumulator. Accumulator, you have to set it equal to 0 at the beginning. So every time user enters a new number, user add it up to the accumulator here. That's all.
It just keeps adding to the total.
Yes, that's all. That's all. Okay, and you can work with disruptor here. Right? So think about you working with disruptor. So think about you have set here total of 0, right? Okay, and every time
We don't see what you're seeing. Sorry.
So every time enter the number, right? Or you have to enter 0 to quit. And now you put this number here. Okay, so now see. That is accumulator set to 0. Now, this is a prime input, right? Remember that prime input, if you put it outside the loop here. Now, enter the number, enter 0 to quit. And now go to the loop. So what do you think? What's the condition here? What is the condition here? What you put in the condition here?
It'd be total equals.
No. How can you access the loop? How can you access the loop?
Oh, to add to the total.
No. If you look on the prompt here, enter a number, enter 0 to quit. Right?
Oh yeah, yeah.
So what you put here? What
Enter
you put here?
number.
Sorry?
Enter number.
Sorry, say again.
Enter number.
No. Here's the condition. Condition is a check. Yes or no. That's all. The condition here is check yes or no. Now, what happened here? You see, enter a number, enter 0, quit, and get the number. That is, you see, enter a number, enter 0 to quit. It is wrong. And the action get the number, you store the number into the memory here. All right, so think about this one. All right. After this one here, right, you have the variable here, and you have the number here. So it's up to any user, and he can enter the number 5 or number 10 or number 15 or number 0 here, whatever it is. Right? It's changeable. It's a variable here. But in order to access the loop here, what do you think? How can you put in the condition here? That's very important. If you work in the selection and the loop here. How can you access the loop if he want to? If he clearly tells that enter 0 here to quit. And 0 here to quit. So what's the condition here? What's the condition here? Enter 0 to quit. That is a key. That is a key point here. Is that compared to 0 or not? Is that compared to 0 or not? It's 0 quit. That's all. It tells you clearly already. So how can we put here in the condition? You compare what? You compare what? You compare number, right? Because the number is something the user enter here. He can enter the number -5, 10, 15, or 0. You have no idea, and you only have the idea that if he enters the number 0, the program quit. That's all, right? So here, in order to do that, you have to check here the condition here. If number equal to 0. Right? If equals 0, you access the loop here. That's all. If not, keep doing it, keep doing it, keep doing it. It makes sense?
Okay.
Okay. So here's the condition here. Because it totally depends on the user, right? He can enter number 10 or number 5 or number whatever or number 0. So action, so duty, it has to check if the condition here, the number here is equal to 0 or not. So if equal to 0, you exit 0. Equal to 0, exit 0. If not equal to 0, what you have to do? What you have to do here? Inside the body here, what you have to do?
Copy the input underneath no.
Right, say again.
Copy the input there underneath no.
Okay. That is a very good point, right? Because you only have to get input again for the next input here. But before that, what you have to do? Before that, what you have to do here? Before that, what you want to figure out? What is the expected output here? What do you want from this program?
After the no, you mean?
Yes, after all the thing you input, what do you want to get from this program here? You want to figure out the total, right?
Yeah.
Yeah. So what action here you have to put here? What action you have to put inside the loop here?
Total.
Yeah, total.
Let's see.
Total equal
to number.
So here, if we set total equal to number here, right? Now think about this one. If he enter number 10, you have the total 10. If he has entered number 20, you have total 20. And if you have number 50, you have total 50. You have nothing increased in the total here. It's a copy from the number to total. Now, you want to accumulate it together. So what do you have to do? You have to set here total equal to total plus number. That's all. You see, this is a new total and this is old total. And remember that variable is something it override. So you see, if we enter the number 0 here, the total at the beginning you have 0. Now we have 0 plus number, you have 10. So now the new total you have a 10. Right? That is the first iteration. The next one, he enters the number 20. Again, total, new total equal to old total. Old total now is the 10 plus 20, you have 30. And if he has entered the 50 here, the new total equals to old total plus number. Old total now is a 30, and the number here is a 50, you have the 80. Accumulate it together. You got it?
Okay.
Okay. So see, you have total here. No, not this one. You have new total equal to old total plus number. And of course, right? You are right. After every time, you have to get the new number here. You have to get the new number here. And you put it down. The total is now see, you can clearly see what happened with the program here. Now run it here. See, total at the beginning you have 0 here. Now enter the number. What I enter the number 10 here. Number 10. Check the connection. The number 10 is not equal to 0, right? You see, check the connection here. Not equal to 0. Keep doing it. Total, you see, new total is old total plus number. Old total is 0, number 10. So now the new total, you see, you have 10 here, right? Now, okay, I get it number 20 here. You see, number 20 here. Check again, the number not equal to 0. Keep doing it, the condition is not correct. See, the new total is old total. Old total is 10, and the number here is 20. Now you have the 30 here. See, that's the way it works here. You got it or not?
Yeah, I just got a little bit confused there.
Yeah. So you only have to clearly about how to check the connection. What you put in the connection here, And what is you have to put inside the body is the loop. It's very important. Okay, so see, you always have to maintain accumulator here. And normally this accumulator, we put number 0 at the beginning. You have initialize the accumulator at the 0 outside the loop. And every time you enter the new number, you just add it up to the accumulator here. Okay. So we have the summary report. It contains only total of no data data, loop are processed, but detailed information is not printed. You see, think about this one, right? You have what is the address, the price, what's the address, price, what's the price, price, and you print out the total here. So in order to do that, you have to maintain the total equal to 0 at the beginning. So if he enters 150,000, add it up to the total. If he enters 310,000, add it up to the total. This one. Come back to my program here. Come back to my program. Now you know how to figure out the total. But my question here, if I want to figure out what's average of all the number you enter, can you do it or not? And how? How you do it? If you want the total now is okay, right? But if you want to do the average here, can you do it? And if yes, how?
Would you just create another loop?
How? So now, if, let me give you the example again, right? So if you enter the number 10, number 20, and number 30 here, after that you enter the number 0 to exit. Now, what do you think? What's the total here? What is the total here?
60.
Yeah, 60. Yeah, right. You have total. Now you see, you figured out what's the total. So how can you figure out the average here? How can you figure out the average? Figure out the average here. So what is average for this one?
Would you divide by 4?
No, not include this one.
Oh, so 3.
Yeah. So how can you tell? How can you tell divide by 3? How can you know it's a 3? If you could think about the program here. So for one time he can enter 2 number, but next time he can enter 10 number or 15 number. How can you tell it's a 15 number or 10 number or 2 number? How? For this one you can see clearly it's a 3 here. But you have to think about the computer. How can the computer know that it's a 3 number?
So I guess it wouldn't know then.
Yeah, right. You have to maintain another variable. It's a counter here. You see, so at the beginning you set the counter equal to 0 here, right? So now enter the 1 number, increase counter by counter plus 1, right? So see, 1, 2, 3 here. So after that you have to total divide by counter. You have average. That's all. You only have to totally think about how to work. You have to put your cell in the computer for you. You cannot instantly figure out the 3 number. You have to do it by maintaining the counter. And every time the user enters a new number, user increase the counter by 1 here. So if he enters the 15 number, the computer knows that that is the 15 number. And if he can enter the 5 number, computers know that it is the 5 number. And user takes the total, you divide by counter, and you have averaging. That's all.
Where would you put the counter within the Raptor program?
It's a deal. Remember, okay, the process is the same. You have to initialize the counter outside the loop. You put the number 0 here, and every time the loop do for 1 time, you just increase the counter by 1. Let me show you here. Let me show you here, right? So think about this one. You have initialized the counter here. Sorry. What is it? I don't know what happened.
Can you hit the back arrow on the top there?
Right. What I put?
I don't know if you can hit that back arrow. Yeah.
Oh, the first change. So here you have what happened? Maybe something wrong with the mouse here. What? Something wrong with the mouse here already. Okay, things are running. Yeah. So I have a counter. You have the counter. You can set a 0. Right? So now I think every time the user enters the number not 0, user increase by 1. Right? So how can you do the increase by 1? What do you think? How can you do the increase by 1? What's the action you have to do if you want to increase the counter by 1 every time? What do you think?
Sorry. Counter equals +1.
Counter what?
Counter equals +1.
Yeah, right. That's all. And now you have the average here. Total divided by counter. That's all. Now see, that it again, right? 10 here. Sorry. Stop it. Now I run it. 10, 20, 30. Now exit. So see, work perfectly, right? Work perfectly. Because you maintain the total. You at the end of the program, you figure out the total here is 60, and you maintain the counter at the end of the program. You figure out the counter here 3, and you just take the total divided by counter. You have average. It's okay.
Yep.
Okay. Okay, so that is one of the some of the common loop applications. Figure out what is the total. Figure out what the average is. And also we can use the loop to validate the data. That it is a defensive program. It's a defensive program. It has to preparing all the possible errors before they occur here. The one from the data. Think about the number here. What is this? Okay, so think about if you want to run the user and put the month here, right? You have to validate that to make sure that the month is the value from the 1 to 12 here, from 1 to 12 here, right? As the one user ask the end user to enter it again. That is a call. It's a defensive technique, the defensive program. You have to prepare for all the possible error, and you have to know how to avoid it and how to make sure that the data is validated and in the correct format. And remember something about the garbage in, garbage out. If you put something wrong, the output is wrong here. So here's the thing. if you want to verify to make sure that the user enters the password here, right? So after here, enter the password, input the password here. Now this is the independent. So this is the independent technique here. You have to check to make sure the month here in the range from the lowest month to the high month here. Low month that means number 1 and the high month here number 12. So see, if month here less than 1 or if month here greater than 12, you know here you do something, right? If yes here, you ask it again, enter the birth month and input the month here. But this is not program, not a good program. That is not a good program. You know why? You know why here? Now see, if you look at this program here, think about if the user enter the month here, 15. So what do you think? It go on this branch or this branch here? What do you think? If he enters the input here, 15, it go on this branch on the left or on the right?
Let's see. I don't think it'll go anywhere.
Huh? No, it can only one branch only. It can only one branch only. Now, see, month here 15. So think 15 here less than 1 or not? Is it true or false?
That's false.
Yeah, false, right? This is false. Now, month here 15 greater than 12 or not? True or false?
Yeah, true.
True or false? True, right? Yeah, okay. So see, you have all here. So if you have false or true, what do you have? You have true table already. So if you have one input is false and other input is true, so what is the output of all function?
So it'll be yes.
Yeah, right. Right? It's yes here. So it's working with yes. Yes here. Input enter the first month and input 1 month. What happened here? If he enters the number 60. So we see this one is not validated again because it moved on. It moved on here. So in order to validate the data here, you should not use a selection. Selection is actually even that he enters the 16 again, he have no way to check it, but keep moving. Instead of that, you have to maintain the loop here, right? So see, if 16, check it again. Is in the range or not? If not, keep doing it until in the range from 1 to 12 here. It makes sense.
Yeah.
Okay. That's why I don't do it. Right? Instead of that, you have to working with the loop here. See, this is a loop here. Right? So you think about this one here. This one. And so if you have enters 15 here, yes, enters the 16 here. Sorry, enter the 16 here. Again, check again. Not correct, check again. Oh, correct. Keep doing it until it is right here. So instead of the validate here, you have to use a loop instead of a selection here. Okay. Common loop application. Okay, but what happened here? What happened if he keep enter the wrong number? It's a 17 or negative 10 for multiple times. It's very frustrating here. The same thing about if you're working on, if you want to log in the IV Tech account, you enter the username and password. What happens if you keep enter the wrong password? So if more than 3 times you got the account locked here, for the account here, instead of allow you to again and again and again, and it have problem with security here. What happens if the user keep guessing the password? Brute force here, right? So see, instead of that, you can limit it. You can limit it here. Limit the reprogramming group here. Sorry. This one here, limiting reprogramming loop. Reprogramming loop can be frustrating to user if it continue to indefinitely. Keep enter the wrong one here. Maintain the count of the number of reprompt and forcing data. Either means that override incorrect data, setting the variable to specific. So think about if you enter the password for 3 times, the wrong password for 3 times, you have to exit it. You can do the same with this one. You maintain the counter, right? Now the first one, incorrect password, increase by 1. The second one, incorrect password, increase by 2. And the third time, again, incorrect password, increase by 3. So we have a counter. Now count to number 3. You say that you already have the 3 attempts. Now you have to log out here. The same with this one. Okay, so now see what this one here, right? What is it? Now, again, you check the condition here, right? You make sure that the month in the range from 1 to 12. But what happened here? If he keep enter the correct one, you have to maintain the count attempt here. Right? And what's the count attempt? Count attempt here, number 3. And you set the count attempt at number 0 at the beginning, right? Where I put the count here. Yeah, the count here, number 0 at the beginning. So you see, every time we enter the wrong password, you increase by 1. The first time, the second time, and if the third time, you exit it here. Right? That is the way you validate it. You can validate by using the loop, and you also limit how many attempts you can have by using the combination here. So whatever, if the count greater than the number of attempts, maximum attempt, you exit it. Right? It makes sense.
Yes, sir.
Okay. Okay, so you can validate the data type, and you know that you have the sum type validate data type here. It can be in numeric format. It's everything number here. It can be character, or it can be in string format, or it can be white space, or it's upper. For many language programs, you can check by the function here. So think about this one. Think about this one here. Let me go back to the router here. Let me run it here. Enter a number. And I enter the number, but I enter the wrong format here. Instead of number, I put the character or string here. See what happened. I have syntax error here. Because it cannot compare string or character to the number 0 here. That is the syntax error here. So instead of that, you can validate. You can validate here to make sure the input number here is in the number format here. The input number is the number format here. So instead of that, you can check by the function. You can check by the function here. So at the put, I could put the loop here. I have the loop here. Input the and the number. So I have to check. Is number. That is for the. What is it? Yes, it's number here. Oh no, it's number. Number. Okay, remember that is number is a function. To check if the variable number here is in the number format or not. If yes, keep doing it. If no, you have to enter you have to enter the number format. You have to enter number format, something like that here. Wrong format. You have to put here wrong format. No, sorry. I did this one. Yeah. Now think about this one. Nothing. Now I done it here. So see, I done here, enter the number. Now what happened here? I enter the wrong one. I check. It's not the number format asking me to enter again. Now if I put the number 10 here, I can do it here. So that is also validated here. Okay, and also you can combine with the number attempt. So you set the number of attempt at the beginning is at 0. So every time he enters the wrong format, you increase the attempt to number 1. And if you have more than 3 attempts, you can force him to exit programming. It's totally up to you. Okay, and basically in the adapter, you have the sum of function, you have each number, each character. You can think about this one. So see, when you have is here, you have some here. Is array to check if it's in the array format or not. Is character, is number, or is string here. So remember that the difference between the character and string, that the character you only have one character, but string you can have a multiple character here. Right? Okay, that is the way you validate the program. Right? And again, this one again also, right? Again also, if you want to do it, you have to copy this one and paste it here. Make sure you enter the correct number here. Okay. This one. Okay, make sure you enter the correct number. This one. Okay, so what else? Okay, so here the thing, right? You input the salary here. You put the salary here, and you have to check if the number here is a number format, is a numeric or not. Right? Is that we doing it here? The same as this one. You have to check it if it's in the number format or not. Is the number format or not? You don't have to do this one. You just do it here. Because the salary is something is a number format, right? And if he enters the character or string format, you have syntax error. That's why you have to make sure the user enter in the number format here. Okay. Can validate the reasonable and its consistency of data. Maybe that item can be checked for reasonable. It's good defensive technique to try to force it. So when working with the defensive technique, that means you can use you can use the coding to validate data here to make sure the user enter the input so correct in the data format here. Because the garbage in, garbage out, right? So in order to enhance the quality program, you have to use the validated data here, defensive technique here, defensive program here. And in order to do that, you have to foresee it, you have to anticipate it. So think about whenever user enters the salary here, you have to check if it is in the number format or not. And the first thing here, you have to check if it is greater than 0 or not, because you have never ever got the salary that less than 0 here. Right? So you see, you only have to foresee it, you only have to anticipate it in order to work with the defensive program. Now, let me give you an example here. If the program asks you to enter the grade or the grading here, grading. So what do you think? How can you verify? How can you validate this one in the grade format here? What do you think? If the user enters grading, how can you validate it? And how? How can you validate to make sure this is in the grading format? What do you think? It is a number format or character format or string format here. What do you think? It's probably in the number here, right? So the first thing you have to check to make sure it's a number format here. The second one, you have to make sure that it has to in the range from 0 to 100 here. So all of that you have to foresee it, you have to anticipate it in order to be working with the defensive program, in order to validate the input here. So what happens if the end user enters the grading it is ABCDC here? It's not correct. And what happens if he enters the number 100, negative 100 here? It's not correct. So that if you ask the programmer, if you ask the coder, you only have to foresee it and anticipate it. All possible inconsistent and error here. It clear or not? Hello?
Yeah.
Okay. Okay, and if you have a common loop application, you have a comparison between the selection. Selection you just do it for one time, right? But the loop you can do it for many times here. Okay. So this is a selection here. Selection, you can do it here. Again. You see, display the code, input the code, display the code, input the code, and you break it down. It's very long here. Instead of that, you just work in the loop here. So you see, you just do it for one time here. Coding, display, and recording here. So this is 1, 2, 3, 4, 5, and so on here. It takes many times, but when you're coding, just do it for one time and check the condition. Do it again and again and again. So that's summary. Loop writes one set of instructions that operates multiple and separate set of data. Remember about the rule here. You have 3 steps. You remember about the 3 steps here. You only have to pay attention to 3 steps. You only have to initialize the loop control variable outside of the loop. That's the thing you have to remember. The second one, you only have to compare the variable to some value in order to exit the loop. It's a condition here to check. The third one, you only have to change the variable that controls the loop. And remember, you have to change it inside the loop here. Right? And the netted loop, that is the loop inside the loop. The netted loop maintains the 2 individual loop control variables. If you remember about the netted loop for the quiz and the question here, right? You have 2 individual loop control variables. The outer one is the number of quiz, and the inner one is the number of the question here. And remember, you have to change each of the operator type here. Common mistake by the programmer, neglecting to initialize the loop control variable. The 3 rules, right? You cannot neglect it. And neglecting to enter the loop control variable, you cannot do it. Otherwise, if I look here, using the wrong comparison, it's the loop control variable, including statement inside the loop that belong to outside the loop. That will increase the processing time and increase the memory of the computer here. And the most computer language support for 4 it is a pretest loop here. The same with the while and while here. Right? And you have the post-start loop. Remember the post-start loop, whatever it is, the body of the loop is always executed at least one time. Okay. And some of the most common application for the loop, it is figure out what's the total and what's the average here. And okay, so I think that's all for the lecture for today. Let's see what is the homework here. And today is a Thursday. What's the discussion here? Okay, you have some of the SQL coding techniques. So for this one, you should watch the 2 videos here. This one you should watch by yourself. So we have some information to do with the discussion here. Execute code. This one is this is watch video.
Loops. Loops are the repetition of a series of actions. Just like a runner runs around a track over and over until told to stop or having completed a specific number of laps, a programmer may need to repeat steps until told to stop or until they have completed the steps a specific number of times. Loops in programming. Loops are a powerful tool in programming that allow the programmer to repeat a series of steps over and over. An example might be asking for a value and adding it to a sum. In a loop, you would repeat these actions over and over. Stopping a loop. You must put a mechanism in place to stop the processing of a loop. If you do not stop the loop, your loop will continue running until you kill your program or the computer runs out of memory. This is called an infinite loop. There are two ways to stop a loop: a sentential value and a counter. Sentential values. A sentential value is simply a value that, when entered, causes the loop to stop. The sentential value selected should be a value that would not be a part of your data. For example, if you were entering salaries, you would not expect to earn a negative salary, so a -1 is appropriate. If you were a runner, your coach might hold a stop sign to stop the run. Counter. A counter is used to control the number of times a loop is executed. Of course, you can only use counters to stop the execution of a loop if you know the number of times it should execute. For example, if you were a runner and the coach told you to run 10 laps, you could use a counter to stop after 10 laps. How do counters and sentential values work? For sentential values and counters to work, you must have a condition that checks the data for the appropriate value to stop the loop execution. You must have a question called a condition statement with an answer of yes or no. Your question might be worded so that the answer can only be true or false. For example, the question might be number of laps less than or equal to 10. If the answer to the question is true, continue with the loop. And if the answer is no, stop the loop. Remember, maybe is not allowed. Summary. Loops are the repetition of a series of actions. Loops must have a way of stopping. Sentential values and counters are used to stop loops. Conditions are used to determine if a loop should or should not continue. If the condition is true, the loop will continue. If the condition is false, the loop will stop. Loops that do not stop are infinite loops.